My name is Richard Boyd. I'm a software engineer, and by trade, I've been doing software engineering for about 8 years in the private sector and about 10 years in the defense industry before that. I've just recently moved into a developer advocate role, so I still do some software engineering, but more of my time is spent meeting with actual developers and feeling what their pain points are and taking that back to the service teams so that we can improve the product. The next hour, we're going to cover a tour of the CDK, which is a new software development framework for defining your cloud infrastructure as code. Right. So we're going to have roughly 4 parts today. Start by giving a little bit of context into this infrastructure as code journey. And then we'll talk about some of the challenges that developers face, some of the best practices that have emerged from those challenges. And then we'll quickly give an overview of the main core concepts of CDK so that we're all using the same taxonomy when we're talking about constructs or stacks or apps. And then finally we'll wrap up with we'll do a demo app, and then I'll kind of do a small demo app, and then we'll just slowly add a little bit of complexity to it based on how much time we have, just demonstrating some of the concepts as we go. And then we'll wrap up with some recommendations on where you can go to learn more about the CDK. So let's hop right into it. All right, so before we get into the actual journey itself, I want to take a small detour and talk about an outage I caused a few years ago. All right, so I used to work on Amazon's Alexa project. Everyone's heard of Alexa, I assume. A few years ago, I couldn't assume that, so it's much better now. And specifically, I was on the personalized model building system. So we built these personalized models for each user just to make Alexa more accurate for that particular user. And inside of Amazon, where Amazon's a customer of AWS, just like any other customer is, just much larger. And we had a fleet of EC2 instances that would have to share some state across all of these hosts. And it was very important that the state was consistent across all of the hosts. So what we would do is we had this kind of 2-stage deployment process, and we're very careful and methodical about how we updated that, because we just stored that state on the actual hosts themselves. So if you've got 70 or 80 hosts and some text file, essentially, that you want to keep consistent, you have to be very careful about how you make changes. So I thought I was going to be very clever and move this shared state off the host and put it into a DynamoDB table. So it's just one shared state. I mean, it's the purpose of a database, right? No. Well, since we only had this like one table, we were doing a test one day, and like any good test fixture, it tore down all the infrastructure when it was done, including our production table. So nobody can enable any new skills for a couple of hours during this outage. And as Amazon's fairly well known for, we do these retrospectives afterwards to figure out what caused this outage. And one of the things that came out of this is that we needed not just separate tables for development and testing and prod, but we needed like separate AWS accounts, like whole new accounts just for prod, dev, test, and also for each of the regions that we were operating in. So North America, South America, EU, Asia Pacific. So this ended up with about 16 individual AWS accounts. So has anybody ever tried to like create infrastructure in 16 different accounts by using the console like all at once? It wasn't fun. All right, so just making the accounts, I was like, there has to be a better way to do this. All right. And also, I thought there was a better way to do this, but after I made all these accounts, everyone's like, well, it's done now. We don't have to make any changes. Like, why are we going to invest in automating it if we've already done it this one time? So it kind of just stayed that way. We had like this run book that was really big, and it said, here's how you add a new table if you want to spin up like a local environment or a local account to do your own testing. There were some machine learning scientists who made some models that we later consumed, which is part of this table process. They wanted to be able to create a version of our microservice so that they could test it before they delivered it, just to speed the iteration on delivering those models. So if you ever worked with data scientists before, if you ever tell them like, oh, just go poke around on this console until it works, it'll never work, and they'll be mad at you for a long time. And we also want to start leverage more and more of the services that AWS is offering, not just tables, but SQS queues, S3 buckets, all these other services that, for each one resource you create, you have to create 16 more, like manually in the console. And that wasn't a very good experience. And the one time I realized that we had more story points in a sprint allocated to updating this run book, or as I called it, the run cyclopedia. we had more points devoted to them than to our actual features that we were trying to launch. So like the administrative overhead of all these accounts just was like swamping us. So I did what any good software engineer would do, is I waited until, oh sorry, I was on call next. Oh, I'm sorry. Okay, it's hard for me to see the slides, so I just want to make sure we're on the same page. Beautiful. Okay. So I waited till I was on call next, and then I replaced all the contents of the runbook with like this script. Right? I think the one shown here is in Ruby, just as a demo. The one I made was in Python. It used a Boto 3 library, and it would just go and create all these resources for you. It was a huge improvement, right? It was, sorry. Where we were spending a whole bunch of time maintaining this essentially a wiki document, we now just had a few hundred lines of code that we would maintain. But we traded one problem for another in this problem, is that when you create infrastructure, you only ever create the infrastructure once, right? But then you modify it tens, dozens, maybe 100 times or so, and then eventually it's deleted, hopefully. It doesn't just like linger forever. But when I wrote this script, all it does is like it just creates the infrastructure. If you want to talk about like mutating that infrastructure into like some other kind of, set a flag on one of the buckets or add some property to a Dynamo table, that wasn't really supported in this thing. And it became very difficult to like update the infrastructure to the point where it was easier to just tear it down and start over again. So that's what a lot of people did until someone accidentally tore down a production table. And we realized like, this wasn't going to work for us. So we moved on to like these resource provisioning engines, which is Cloudformation and Terraform. What I really liked about these is that you just give them a desired state. You say, this is a state I want in my infrastructure, and the provisioning engine will look at the state, it'll go look at what state your infrastructure is in now, it'll figure out what the difference is, and then it moves your infrastructure into that state with the appropriate API calls. It handles rolling them back if there's any kind of a mistake. It handles updates, it handles everything for us. So we can just focus on just describing the desired state of our infrastructure. And it really, it feels like magic the first time you use it, because you're just like, here's what I want, and then you give it to Cloudformation or Terraform, and what comes back is exactly what you wanted, hopefully. Oh, sorry. I didn't know I had advanced yet. But what I found with these is like, they're very verbose, right? I describe it as like a very evil genie, right? You say like, this is what I want, and it gives you exactly that. So you have to be very, very clear about like, I want this, and I want this property set this way, and I want this property set this way. And you end up with this very large Cloudformation like YAML document specifying all these properties. There's no opinionated defaults, there's no abstractions. It's just verbatim, this is exactly what I want. And it'll get you there, but it's like you have to be very, very clear about what it is that you're doing. And I found that I was spending most of my days just like copy pasting like JSON and YAML, or converting between JSON and YAML, because I found a sample that I wanted, but it was in JSON. The rest of my template was in YAML. One time I tried to just like paste it in there and it kind of worked, but then it didn't get through code review, and I was really upset by that. But yeah, this is why I was hoping that they just wouldn't put me on call anymore, but it didn't work out. Right, so after a whole bunch of times like copy and paste all this YAML code, we're like, there has to be a better way. And I tell people I did some Googling, but actually a friend of mine just pointed me to these document object models that it's like they allow you to generate Cloudformation templates based on this like DOM structure, right? And it felt closer to what we wanted to do, right? You could, I wanted the power of like Cloudformation that was, it was declarative, and it handled the provisioning engine portion of this, where it moves my infrastructure from one state to another, so I don't have to think about all that. But I also wanted to just be very terse in what I say. This is what I want. Like, I have no preferences for how many capacity units are on my Dynamo table. I just want a table that works right now, and I'll worry about that later. And this is what the DOMs gave us. Right? They gave us this abstraction on top of the Cloudformation, and allowed us to deploy our infrastructure. One of the first times we get to deploy infrastructure is what some people call real code. I call it like familiar code, right? Because you have in this code that looks very much like YAML. I think this one is Troposphere, is the demo that's shown there, which is in Python, right? So you get all of your Python features from your IDE. Did my mic turn off? Did the mic turn off? Oh, I'm sorry. Maybe like the echoing stopped, and then okay, sorry. I apologize. Now I lost my train of thought. Right. So you're yeah, you can use PyCharm or whatever IDE you use, and you get like tab completion and inline documentation, and all these great things you like about using IDE. And the reason people don't just code in like Notepad, right? But they offered an abstraction, but an abstraction wasn't like a first-class citizen in these object models. So like you couldn't like wrap up everything you did as an abstraction to give to someone else, right? So if someone else wanted to do this, they would just copy and paste your Python code instead of copying and pasting your YAML. So we're only like slightly better than we were with the previous provisioning engine models. So this is where AWS stepped in. Coincidentally, this was right as I had like left AWS to go to iRobot because I was on a different team as this was being launched. Those two were unrelated. I'm not saying I left because they launched us. That'd be a terrible thing to say on camera. So AWS offers like all these services. They've got like hundreds of services, and I should probably know the exact number, but I don't. And we want to use more and more of these, and as more are launched, they make services that are more specific to individual use cases, right? You went from just a general purpose database to now you've got a graph database, you've got a document database, you've got a key value database, you've got a SQL database, if that's what works for you. Right? So as we have these more and different types of resources, it becomes harder to manage having all these different resources. It becomes very complex. So the CDK team was formed to create an abstraction that helps developers manage this infrastructure, the complexity of this infrastructure, like minimize that complexity to make it easier to reason about. So I'll quickly cover some like core concepts, and we'll jump right into writing some demo code. We'll be writing Python or TypeScript for the rest of the demo. Right. So one of that is very core. Like the CDK is a software framework for defining infrastructure for your cloud applications. And this code that you write in this framework is called your application. I know that word application is used like quite a bit, but when I refer to a CDK app or CDK application, I'm referring to like this specific framework feature, which is just a collection of your constructs. Right? And it is a collection of your stacks. I'm having trouble saying that. It's a collection of stacks. You could have one stack, you could have hundreds of stacks, or maybe thousands, depending on what Cloudformation gives you and how you spread them out. If you have 1,000 stacks, I'd really like to talk to you in the hallway afterwards. And then each stack contains what we call a tree of constructs, right? Or a construct is a AWS like cloud resource with some configuration attached to it, or no configuration, depending on how you use it. But we'll just say that no configuration is a special case of some configuration. And the key to this is like the abstraction, right? The CDK programming model like allows you to bundle up these constructs as like abstractions that you can pass around and publish, which we'll talk about in a moment. And then it also this allows you to keep using like the Cloudformation, or your IDE resources that you had before, so you can still do inline documentation. You can still do the testing tools you use. So for Python, you can use PyTest, or JavaScript or TypeScript. You can use Jest to test these. You can use your IDE to do like tab completion, like I said before, type hints, things like that. I'm not sure how many people like memorize like the standard library for applications, but I normally just press like the dot, and then I look at all the methods that are available and kind of look for the one that's similar to what I need. Or if I'm like creating a class, I'll do like the opening parentheses, and then I'll see like all the things that it expects, right? And hopefully it tells me which ones are required or optional. If anyone writes an API and they don't like put documentation in those, I don't want to talk to you in the hallway after this. We're not friends. And we also have, my slides and my notes got mixed up, I apologize. And because we're still working on top of Cloudformation, we still are able to leverage that provisioning engine, right? So you still don't have to think about how am I going to move my infrastructure from one state to another. You just give it your desired state. We're just using the CDK construct library and the CDK core application, the software framework, to create this Cloudformation representation for you. So you can focus on just like the code. It lowers like the amount of like cycles like mentally you have to use to like think about your like the Cloudformation syntax, so you can spend more time thinking about what your application is doing. Did anybody attend the last talk in this track upstairs, the Palumi one? Right. Yeah, no, exactly. So you talk about how the line between infrastructure and application is like blurring, and it's true, right? I mean, that's why he's going to talk about it. How your infrastructure is configured like greatly affects the way your application performs, or if it performs. So the more time you can spend thinking about that, and the less time you spend thinking about the underlying like implementation details of mutating some resource, like the better applications you'll produce. Right? Which is, I hope, generally true. The more time you spend thinking about something, the better you are at it. If that's not true, I'm sorry. All right, so we have this thing called the construct library, which I believe this is one of the last resources we'll discuss here before we start writing code. I really wanted to start writing some code, but they said I had to talk first. Okay. So we have this construct library, which contains, I think this is just a snapshot of the cover. So this is just, we have modules and constructs. Each AWS service, more or less, is composed into its own separate library, so it does its own versioning. Some are marked as stable in GA, some are still experimental based on how much support, how much development has been done on them individually, or how confident we are in them. And we also have a few extras that we've added as like helper functions. Has anyone ever tried creating a Cloudformation custom resource in Cloudformation? Like, anybody? Nobody? Yeah, it's kind of hard, right? Like, don't tell anyone I said that. But like, it takes a while. It takes like trial and error quite a few times. And usually you use a custom resource because you just want to do like a single AWS SDK call that's not supported in Cloudformation. So we added this AWS custom resource package so you could just describe that SDK call that you would make in your code, and it would just deploy that as a Cloudformation resource, which unlocked a huge potential. So even though we're still built on top of Cloudformation, we're allowed to offer a lot of features that Cloudformation doesn't quite support yet. So the ACM custom certificates that are used, I just recently used it for like Athena tables, which don't quite have as much Cloudformation coverage as I'd like. Right? And then we'll talk about, Hill mentioned constructs as L1, L2, or L3. L1 constructs are a way that, because we're built on Cloudformation, if you really wanted to, you could write Cloudformation in Python or TypeScript, whatever language you wanted to use. It would be very, I want to say it would be difficult, but it wouldn't look very nice, and you wouldn't accomplish much more than just directly writing the Cloudformation itself. You could do something, it gives you some benefits, because Cloudformation will tell you, this is supposed to be a string or this is supposed to be a number, and your IDE will say this is supposed to be a string or a number. But if it's supposed to be like an ARN that's just represented as a string, it's not going to know if that's a correctly formatted ARN. It'll just say, sure, I'll take that, and then when you deploy it, it'll fail. So the L1 constructs are just your like base Cloudformation resources. And then L2 constructs are those resources, but with opinionated defaults built in. So the example I like to give is like a VPC. If you've ever created a VPC in Cloudformation, it's about 350 lines of Cloudformation. You have to create NAT gateways, you have to create private subnets, public subnets, route tables, internet gateways, CIDR address blocks for all of this. With L2 construct, we say, like, if you tell us, I don't care what resource, what configuration this VPC has, just give me a VPC. I need a VPC to put an EC2 instance in for something. I'm going to tear it down in a minute. I don't care about any of its settings, just make it work. It's a single line of CDK, and it's just, new VPC. And then we will give you, I think, 2 public, 2 private, 256 IP addresses in each one, I think, are the defaults. So we provide a lot of opinionated defaults, and then you can like slowly peel back that abstraction if you want to. If you say, well, I'm a little more picky, I want to have exactly 1 public subnet, then you supply just that to the constructor, and that's what you get. So I describe this as like peeling an onion, where some of these other tools are more like cracking an egg, where as soon as you deviate from the opinionated default, you have to just do everything yourself. You open an egg. Yeah. Also, this project is open source, so we have it on GitHub. I made a few contributions while I was at Amazon before, and then while I was at iRobot, and then I've made a couple since I came back. It was easier for me to make contributions when I wasn't working for AWS, just because with Amazon and AWS technically being separate companies, there was some, I had to go through more reviews, but at iRobot, just do whatever you want. I did it on my own time. It's not like iRobot was paying me to do it. All right, so let's get into some code. All right, so let me close this. I'm gonna have to, I think my screens are, they're extended. I need to, all right, so let's get into some code. 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 All right, so let's get 1 second. No, that's not what I want, sorry. I just set up my display just for, no, I got it, I just gotta figure out where this is at. There it is. Yeah, now we're gonna mirror. It is warm up here. Okay, everyone can see all this crap on my desktop. All right. So I'm gonna minimize this for now. That got moved around, I don't know what that is. So this is where I was playing earlier, but we'll open it back up later. Can everybody read that, or should I make it bigger? What's that? Can someone like turn the little thingy on this? I think that's how it's done. Oh yeah, that is fuzzy. Yeah, it's a projector. That's why I couldn't see. Okay, this is where I was playing earlier, so let me just clear this. Okay. Let me just remove this so you guys know I'm not cheating. Okay. All right. So we're going to start with, I apologize. We're just going to make a directory. What are we going to name this application? You and the orange, what are we going to name it? I don't. Okay, what's your name? Matt. Okay, Matt's new app. Matt's new app. Okay. I'm almost there. Okay. So every time one of the benefits of CDK is that you can use a language that's like familiar to you. So you can use Python, or we have general availability support for Python, TypeScript, JavaScript. We have a developer preview for Java and C#. The user experience for those two isn't quite where we want it yet before we're comfortable saying it's general availability, but it does work. I mean, a lot of it's just, if you're using Java, you have to then, because it's originally written in TypeScript and then uses JSII, which is this tool we want to like transpiles into these other languages. Java developers don't want to have to know about like using NPM and like doing these other things. There's what's the term for the workflows that people use for building Java apps? I just don't know off the top of my head. Either way, it's not important. Okay, so I'll let you, every time we do this, people complain because if we do Python, they'll say, I was hoping it'd be TypeScript. If we do TypeScript, they say, I was hoping it would be Python. So I'll let you pick. Just raise your hands if you want it done, this demo done in Python. Okay, raise your hand if you want it done in TypeScript. Yeah. This guy's trying to vote twice. Okay, Python added, right? So we'll do CDK init. This command by itself won't do anything. It'll just tell me how much I messed up, hopefully. And this gives you your options, right? So you can do just a regular app, which is a blank project structure, a library, which we'll cover in a moment, or a sample app. We're going to do a sample app. I always misspell language. Python, and then you say which template you want. So we'll say sample app. And it creates a virtual environment for us. I've been asking the team to like have it automatically like source the virtual environment, so I don't have to like do that. And they said that was too lazy. Like that was like a bridge too far. They wouldn't support that. But they do give you the command, so you can just copy it and paste it. All right, so we're gonna use this this virtual environment. I may have already been using it differently. Either way, it'll be fine. And then we're gonna pip install the requirements for this. And while that's working, I don't know what this is. Open. That's new app. I'll make this bigger in 1 second. Maybe I will. Okay, bigger. And so because you all chose Python, I hope you're familiar with this, right? This is a requirements file. It'll go into the setup.py and pull in these dependencies. And by default, the application that we give you, we'll look at it real quick. Oh, I have to zoom on each one. That's annoying. So we'll just quickly walk through this. We can ignore this hello construct for now. We import, IAM, SQS, SNS, a simple queuing service, notification service, and then a subscription thing for SNS. And then you get a SQSQ. Because how do I put this? Every object is like part of a construct, right? And the constructs have to have a reference to like where they want to be put. So we always like start with self, saying that we're going to add it to this my stack. You could, if you wanted to, like pass in some other stack to attach it to, but that feels kind of like violating some weird computer science, software engineering principles about like encapsulation and data hiding. You could technically do it. I'm not saying don't do it, but don't do it. And then you have to give it a name. If you've used Cloudformation before, this is very similar. Oh, thank you. I think he's trying to give me a hint. Thank you. And my voice has always been very raspy. I'm not like especially sick. There's a lot of people who like meet me that like the first question they ask is like, "What's wrong with your voice?" And I'm like, "It's nice to meet you too. Please don't insult me." It's been this way since I was like 12. And I apologize if it bothers anyone, but it's how I sound. And then you pass in these options. Right? A queue has a visibility timeout. It's a common option. SNS topic. This is a construct that we're actually going to get rid of. We're going to get rid of all of this. All right. And I'm going to we're going to create more or less from scratch. I like this because it gives us a lot of like the templating for this. We're going to create a SQSQ that messages come into it, and then there's a Lambda function that takes those messages and like writes them off to CloudWatch logs. Mostly because you can write to CloudWatch logs just by printing it. It's a cool thing about Lambda, so it allows me to be lazy. So first thing we will do is we will import Lambda. This is a problem that you have when you're writing a thing that compiles into many other languages. If you look at the reserved keywords across Java, JavaScript, Python, C#, there's not that many words left, right? So if you want to use, wrong button. If you want to use like Lambda, it treats this as like the Python Lambda. And it's like, sure, that can be a function. I'm like, that's not at all what I want. So like the idiomatic way I see people doing this inside of CDK is they'll just add an underscore to either the beginning or the end, or they'll abbreviate it. Sometimes I'll create these, like import these as with just like one character. I do this for the code tools a lot because that's the tools I focus on. So like code build, code pipeline, code commit. I just call them CB, CC, and CP. And I get yelled at like all the time. Like, this is unreadable. I'm like, that's the way I like it. Okay, so we'll create a fn equals, doing the TypeScript one, sorry. Lambda.function. All right, so this tells you like the resources that are available inside the Lambda service, right? So there's Lambda, there's anything that starts with a CFN is the L1 constructs. So if you really wanted to write Cloudformation in Python, you could do it with this CFN. I'm not going to give you all the choice to do that today because I know you'll make me do it. And then we say self to say where to attach it. We give it a name. Maths function. And then you probably, it's hard to see. Where's it at? There it is. So I apologize if this is too small. There's no way to make that bigger. But it's saying that there's a code handler and runtime are undefined. So that means that this will fail if I try to compile this, because those are like required properties. So we do offer a lot of opinionated defaults, but there's some things we just can't guess. I can't guess what your code is going to be. If I could, I'd be making a lot more money and I wouldn't be working for someone else. So we're going to say, ignore my formatting. It's just for the demo. I don't normally half indent things. So the first thing we'll do is runtime. Say Lambda, runtime, no, runtime. And then here are the runtimes as like an enum. I love this because when I try to use like regular Cloudformation, I can never remember if the P in Python is supposed to be capitalized or not, and I'm always wrong. Like I try to remind myself, okay, it's not capitalized, and I won't capitalize it, and I'm like, oh no, it is, or vice versa. Or the actual version, there's like node, oh wait, there's like Node, different versions of Node that are described different ways. I can never remember the syntax, so I just have to go and look them up. This just like lists them as an enum of what it accepts. And this thing that just popped up here, I know it's hard to see. These are all the possible options you could give it. So we saw that there was like the 3 required options, but we do still support if you wanted to, add layers, or what are some of these other ones? Add a description, which I never describe anything because that's like documentation. You want to add some events to this. You want to create a custom role and assign it to it, like that you can also do. But if you don't supply a role, we'll give you the basic Lambda execution role. And then handler. So I know this seems like just like an incantation. Oh wait, I just covered it up, I apologize. Index.main is the handler. If you've created a Lambda function before, you know that you have to say like an entry point into the function. We're going to do what's called like an inline Lambda function, where you you put the actual code in the Cloudformation document itself. And in that case, there's no file name, which is normally the first word here. It's just called index. You just have to know that from the docs. But you can also do something that I'll show you. Code equals. So yeah, I just did it there. Code. So you could say like from asset. I think there's a from directory. I don't know where that one's at. So you can say like from asset, and you can like pull in. You can say like, okay, this whole directory is a Lambda function, and it will handle zipping that up, uploading it to S3, adding in the correct keys for you. Seems weird, like more echoey if I'm over here. So I'll just do this. We're just going to do like from inline, and I'm also going to do something very gross where I'm going to write Python just in one straight line across. This is going to be our function code, similar to what the guy in the Pulumi talk did earlier. Right? So we're going to say def main. Does anybody want to bet if I mess this up? Yeah, I missed this colon when I was practicing earlier. It took me forever to figure out why it wasn't working. /n. Of course, you have to indent it because Python likes white space. Print event. I always say that white space is the best form of scope. All right, so now we just have a Lambda function. Let's come back here. We can do CDK synth to synthesize our template. I think there's an extra space there. Hopefully it doesn't break anything. That was anticlimactic. I'll make it better. So inside of our app, and I apologize again, I can't make this side bigger, but I can make this bigger. So this is the app I referred to earlier. It actually creates 2 stacks just to demonstrate this, but I'm going to delete this one because nobody cares about US West 2. And we'll make this the best region, US East 1. And we'll try this again. So if you have more than one stack, it'll just output all of them to a folder and say, okay, I'm done. If you only have one stack, it will print it out for you in like the synthesis command. Which if you were doing this in like a production environment, like into the folder, would probably be a better approach. And then this is the Cloudformation that I created, right? So it creates Matt's function, it creates the role for Matt's function, creates the function itself. This is the syntax it uses for this hopefully correct Python code. And then references the role. And then we add in this this metadata, which helps like debugging this. So if you wanted to see where a specific resource came from, you could kind of dive into this and see where that came from, what version numbers were being used. Inside that cdk.out, this file, this folder, do this. So we also produce this manifest file, which describes the resources and a stack trace for each of those, whether they passed or succeeded. They still get the stack trace to help debug it if you're not sure where a resource came from. Because if you have like layers of abstraction on top of layers, it's really hard to tell like where did this thing come from. Because sometimes in the templates they'll just show up in the same as like peers in the template. Okay, so we will. This looks good. CDK deploy. I'm going to use a profile. If I knew the name, let's see if I can go to my history. There it is. That's just a profile I use for demos. I still want to have to open up like my config file and show everyone my credentials during a recorded screen. Oh, is that me? Okay. Oh no, what's this? Okay. So this is a bug. This is a Richard bug. What happened was earlier I deployed this stack with this same name as like a demo, and I'm sorry, where was it? So it gets this name hello CDK1. That was like the default name. I didn't change it, and I made a couple of changes to that thing I created earlier, and now we're doing this again, and it's trying to like overwrite that, but it's telling me you're going to like remove this policy if you do, which is this SQSQ, which makes sense. So by default, what you get in this diff, anytime you do a CDK deploy, it'll show you any IAM role or policy differences, because those are like the most important ones that people tend to care about. You can force it to say, show me all the differences, but you can also do, let's just say no for now, CDK diff. And this will show you the actual differences if it runs. Yep. And it's adding a new role and a new function. I'm not sure why it's not mentioning getting rid of the queue. I'll have to look into that. But I will do this. And if you wanted to put this, it'll prompt you for like the yes or no. If you want to live dangerously, you can say like force, I believe is the command, and it'll automatically just like say yes to these things. Or you can just tell it to never prompt you if you really want to like live on the edge. There's probably a vendor here who will like sell you a tool that'll like scan it for you so that you can just auto push it. And if not, maybe there will be next year. Okay, so this is creating the change set. Let's hop over into the Cloudformation. Oh no. What happened? Am I out of time? All right. All right, in this update, it's saying update in progress. I totally messed this up. I should have deleted the stack first, so I didn't do this. Normally it would say create in progress. We'll see these events. Resources, which one resources are created yet? Oh no. And we'll get this. Okay, so we'll let this deploy or not. It might fail, we'll see. But let's go back to the code. Unless everyone wants to like watch Cloudformation deploy, in which case we can do that. So let's also add, I kind of spoiled it with the CDK diff, but let's add a queue. Equals Lambda, oh nope, not Lambda. SQS as, oh, it was already there, I'm sorry. Yeah, well. This is why they don't let me write code anymore. That's Q. And that's it. We can put like a visibility timeout like the other one had originally, but we'll just leave it off there. More of those opinionated defaults. See what this is doing. This is deleting something. Oh yeah, it's deleting old resources. That's why it's taking so long. Okay, we'll go back into our code. And, right now we just have, we have a Lambda function and we have a queue. There's no connection between those two. So what you can do is you can say queue, this is why I wrote this already. You can say grant consume messages. And that has just created the scope down IAM permissions for IAM to be able to consume messages from that queue. So you don't have to worry about like, oh, what's the right string you have to get from the IAM docs. You don't have to worry about any of this. It gives you the correct permissions for this queue for that Lambda function. So that allows the Lambda function to consume from the queue. But what you also need to do is to give the queue permission to invoke the Lambda function. Right? So you just say grant invoke. Actually, that's not it. add event source. We're going to add it as an event source. This is looking for this thing called event source, which is very small and no one can read it, so you just have to trust me. I have not earned very much trust in this session. And I always forget what this is called. I think it's like event sources. And it's going to say it doesn't know what that is because I haven't imported it. So the way I generally prefer to do it is just to copy this. This is another reason Python's better than JavaScript and TypeScript. It's because I can have these trailing commas and it doesn't throw an error. I think it's actually Lambda. Yeah. A smart engineer would just do this. AWS. Lambda event source. Yep, there it is. I mean, all I needed was a name, so I'm not going to wait. This Wi-Fi is really slow. Lambda. So it's still red because I added it here, but I have to actually execute the pip install command. Okay, and while that's installing, we will look at the Cloudformation. This is done. Where's the function? Oh no, where's that? Anyone see it? I don't see it. Oh, there it is, Matt's function, way at the bottom. All right, so it's here. Oh no, what happened here? This demo is going way off the rails. Let's see, maybe it worked. Especially in TypeScript, sometimes like it'll work. It'll like get through the build and like enough of the install that it like works, and then it'll throw a bunch of errors, and I just suppress those. Application auto-scaling. I don't know what's going on here. So what this could be is that there was a version of CDK 1.16 was released this morning, and there was a regression in one of its dependencies that was then fixed, but it broke my demo. And it looks like I fixed the demo for the regression, and it looks like they put in a patch, so they like unfixed it. Shit, man. Try it again. Sorry, these service teams hate me. You bring down their service twice and never forgive you. Fingers crossed it works this time. Oh no. That's like more errors. I don't know what's going on there. Okay, I think we have to call it there because normally this would work. I apologize. This is a terrible look. I get it. This is a terrible look. Yeah, so the point was that you can say add event source, and then you could say sources, and then it would list like all the possible Lambda event sources. I believe the number is 47 that Andy Jassy last publicly mentioned. And we've implemented like a dozen of those. And it would be SQS event source, and then you point it to the queue. And normally that would work if a better engineer were up here. So I'm just going to call it a day on the demo. We still have 6 minutes. I'll go back to the slides that I closed. Did I close them? I don't even know where my slides went. They're just completely gone. What's that? Oh, the minimum. Oh, yeah. See, it's because it's out of focus. That's why.
What's out of focus?
Exactly. Yeah. And we got some next steps. All right. So we have a workshop where hopefully you'll have better luck than I will getting this to work with the versions. The versions aren't pinned in that one, so they still have the same issues. You can check. There's a Gitter channel, and on the actual GitHub itself, you can post issues. sometimes I'll just like post an issue that's like, I don't like this, and like nothing else, and it'll stay open for a while. They're going, oh, this is very good feedback. So, and then we'll also have sessions at reInvent that's coming up at the end of the month, early next month. Cool. Thank you. And for any questions, I just take them offline in the hallway. Like seriously, this time, like I can talk to anyone out in the hallway. Even if you did the no documentation in your API thing, like, that was just a joke. Cool.
Cool. Thank you, Richard.
Thanks, Joe. Thank you.